In this lecture, we will be discussing a few more improvements over classical TCP. First concept we will be discussing is fast retransmit or fast recovery. So whenever a mobile node moves from one foreign agent to another foreign agent, often it will result in packet loss. It will result in loss, and in such cases TCP will react with a slow start, although there is no congestion. In such cases there is no congestion, but TCP will assume it as a slow start. It will assume it as a congestion and it will react with a slow start. So one of the proposal is to artificially force the fast retransmit behavior on the mobile host and the correspondent host side. That is, as soon as the mobile host registers to a new foreign agent using mobile IP, as soon as the mobile host registers to a new foreign agent using mobile IP, it starts sending duplicated acknowledgement to the correspondent host. Okay, it will start sending duplicate acknowledgement to the correspondent host. So the proposal is to send 3 duplicates. This will force the corresponding host to go into fast retransmit mode and not to slow start. That is, the correspondent host will continue to send the data with the same rate as it was doing before. As the mobile host may also slow start after moving to a new foreign agent, this approach also puts the mobile host into fast retransmit. Okay? The mobile host also retransmits all unacknowledged packets using the current congestion window size without going into slow start. So this is the overall working philosophy. That is, whenever a mobile host moves from one foreign agent to another foreign agent, there will be loss of packets. Okay? But this is not due to congestion, this is due to the handover. But TCP will assume this is congestion and it will react with a slow start. So to avoid this, we can force fast retransmit artificially. It is, as soon as the mobile node moves to a new foreign agent, it will send 3 duplicate packets to the correspondent host. So because of receiving duplicate packets, the correspondent host will retransmit those packets instead of going into slow start. Similarly, this should be enforced in the mobile node end also. The mobile node also may get into slow start. Okay, so the mobile node is also forced to continue sending with the actual window size and not go into the slow start after registering to a new foreign agent. The advantage of this approach is simple changes result in significant higher performance. Some slight changes were required, but it results in good performance. Okay. The disadvantage is it's not a transparent approach. It mixes IP and TCP, Internet Protocol and Transmission Control Protocol. Okay. So this is one uh, improvement. The next concept that we will be discussing is transmission or timeout freezing. Transmission or timeout freezing. Okay. At some cases, mobile host can be disconnected for a longer period of time, and no packet exchange is possible during that time. Example, if a car is going through a tunnel and it is disconnected from the mobile network, okay, or disconnected due to overloaded cells or multiplexing with higher priority traffic. TCP disconnects after timeout. So generally what happens in the sense in such scenarios, TCP will disconnect after timeout. Instead of doing that, this transmission or timeout freezing approach, what it does in the sense, Whenever whenever such long disconnections were happening, that can be identified by the MAC layer. That can be identified by the MAC layer before the TCP does. So the MAC layer is able to detect such interruptions in advance. So MAC can inform TCP layer of the upcoming loss of connection. Whenever such loss of connection occurs, MAC layer would be able to detect in advance. So the MAC layer can inform the TCP about the upcoming loss of connection, and TCP stops sending. But when TCP will freeze at that moment, when TCP knows that there will be a loss of connection, so immediately TCP will freeze. That is, it will stop sending, but but it will but it will not assume congestion. It will not assume congestion because it knows that there is a network disconnection, and the MAC layer will again signal if it is reconnected. Okay, so the window size and all will not be changed. The window size will be set to the same window size. Okay, but the connectivity will be freezed. No data will be transmitted. Okay? So this concept is called as timeout freezing. Situations, there may be disconnection for a longer period of time. No packet can be exchanged during this time. Example, when if a car is going through a tunnel, or if a car is going through a tunnel, or TCP disconnects, uh, or overloaded cells, or multiplexing with higher priority traffic, in such cases, uh, there may be disconnection for a longer period of time. Okay, so generally during that time, TCP disconnects after the timeout. Okay, to avoid that, what can we do in the sense MAC layer can often detect this interruption in advance. So the moment MAC layer detects this, it should inform the TCP. So the TCP is aware of the upcoming disconnection, and also TCP knows that this disconnection is not due to congestion. So TCP will just freeze the connection, okay, without changing the window size and all. That is, it will stop sending, it will freeze everything. So the advantage of this approach is the scheme is independent of data. Okay. The disadvantage is TCP on mobile host has to be changed. TCP on mobile host has to be changed, and also the mechanism depends on the MAC layer. So if you are changing MAC layer, then you have to change the correspondent host also. So that may be difficult because you cannot change the MAC layer of all the nodes in the entire world, right? So that is the disadvantage of this approach. So this is how transmission or timeout freezing technique works. The next approach is selective retransmission. TCP, the acknowledgements that are sent by TCP are often cumulative. That is, acknowledgement N acknowledges N packets were received correctly and in sequence, okay, up to N minus 1. Okay. The acknowledgement for N says that all packets up to N minus 1 were received correctly and in sequence. Okay. If single packets are missing, quite often whole packet sequence, the beginning at the gap, has to be retransmitted. Normally, if some packet is missing, then it is not that only that packet will be transmitted. If a single packet is missing, generally what happens in the sense from that packet, uh, all the other packet will also be retransmitted. So this is called as go back n, but this wastes lots of bandwidth. Okay, so selective retransmission is one solution. RFC 2018 allows for acknowledgement of single packets, not only acknowledgement of in sequence packet streams without gaps. Okay, sender can now retransmit only the missing packet, that is a non-acknowledged parts of the byte stream. So this concept is called a selective retransmission. The advantage is it will be more efficient. The disadvantage is more complex software in a receiver is required. More buffer needed at the receiver end because it should be able to retransmit the missing packet. might be a problem in really tiny devices because they may not have the sufficient memory. Selective retransmission simply says that instead of using go back N protocol and retransmitting all the packets starting from the missing packets, just retransmit only the packet that is missing. Okay, so it will be more efficient, but the disadvantage is it needs more memory, so it may be difficult in case of tiny devices, and it may also need some additional softwares to be installed. So this slide compares the several improvements over the various TCP techniques on conventional TCP. So whatever we have discussed so far, indirect TCP, snooping TCP, MTCP, fast retransmit or recovery transmission, timeout freezing, selective retransmission, and transaction-oriented TCP. Transaction-oriented TCP we have not discussed, but to brief it, normally how a TCP works in the sense it will set up a connection and then data transmission and then it will release the connection. For setting up a connection, three packets should be transmitted. One is connection request, connection accept, connection acknowledgement. This will set up the connection and then data transmission. And then for connection release also three packets are required. Connection release request, connection release accept, connection release acknowledgement. Okay. So even if a node wants to transmit only one data packet, for that also there are seven packets should be transmitted. Seven packets should be transmitted. Okay. So this connection, this establishing connection, releasing connection, and spending three packets or totally six packets for that, it is fine as long as the data transmission is huge. But if the data transmission is very less, then it means that it is not an efficient technique. So the connection setup and release were combined with data transmission such a way that the connection setup and release all can be done with lesser number of communication. So that is called as transaction oriented TCP. Okay. So let us see a brief overview. Indirect TCP, it splits TCP into two connections. Okay, as we have discussed. So the advantage is isolation of wireless link, and it is simple. The disadvantage is loss of TCP semantics. Snooping TCP, it also splits the TCP connection into two. It snoops the data and acknowledgement and performs local retransmission. The advantage is it maintains the end-to-end semantics. MAC integration is possible. The problem is with if the data is encrypted and it does not isolate the wireless link, it don't isolate the wireless link as good as the ITCP. And then coming to MTCP, it splits the TCP connection and it chokes the sender window via window size. Okay? It maintains end-to-end semantics, handles long-term and frequent disconnections. The disadvantage is bad isolation of wireless link, processing overhead due to bandwidth management. And then we have discussed for fast read transmit and fast recovery. It avoids slow start after roaming, that is after changing the a foreign agent. It is simple and efficient. The disadvantage is it mixed layers. It's not transparent. And then we have discussed transmission or timeout freezing technique. It freezes TCP state at disconnect, resumes after reconnection. Advantage is it is independent of content or encryption, works for longer interrupts. But the disadvantage is changes in the MAC layer is required. And then we have discussed selective retransmission. It retransmits only lost data. The advantage is it's very efficient. The disadvantage is more complex software is required and buffering is to be done at the receiver end. Then transaction oriented TCP, it combines connection setup and release and data transmission. The data transmission will be combined with connection setup and release. It is efficient for certain applications. Changes in TCP is required. Okay, it is not transparent. Right. So that's it about this lecture. So let us stop here. Thank you.